let's go to page 914 and start with number 1. Okay, you're looking for limit of square root of x minus 2 over x minus 4, x approach to 4, and you want to make a table. Okay, so you have x, you have f of x, and you're looking for all these values. Okay, so when x approach to 4, that's your middle number, so that's where you want to put like 4 right over here. Okay, and so when you have to make your own table, that's what you want to do, put a 4 over here, and you can get the value next to the 4. Okay, so for this one, the values are given to you, so you don't have to worry about that. But as you go, you want to put that value over here, so that way you know what number to put on the table. Okay, so all you have to do is enter the value of x into the equation. Now, when you use your calculator, you make sure you know what to do with your calculator. It's very important that you put parentheses around the numerator and denominator. That way, avoid a lot of mistakes as you enter it. So you can put parentheses, 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 parentheses. Okay. So as you enter each number, okay, so this will give you 0.2516. Usually 4 decimal place would be enough. Again, you enter each one. This will give you 0.2502, and this one will give you 0.2500. And when you work this way in, you get 0.2485, and this one you get 0.2498, and the next one you get 0.2500. So as you can see, it approaches 0.25. Okay, so this will equal to 0.25. Okay, for number 1. Okay, let's go to number 3. You're looking for the limit as x minus 1 over x cubed minus 1 as x approach to 1. So you can make your table. You have the x, f of x, and the middle, and then you divide into 3 more sections. Okay, so approach to 1, so 1 would be right over here. So, and then the value that you need would be 0.9, 0.99, 0.999, and you got 1.001. 1.01, 1.1. Again, as you enter the calculator, make sure you use parentheses. It will help you avoid careless mistakes. So you can enter the parentheses, as you punch in the numbers on the calculator. So you're going to get 0.3690, 0.3367, 0.3337. And as you work on from this side, you get 0.3021, 0.3300, and 0.3330. Now, look, when you get over here, you get the same value, then you know it's approach to that line. Over here, you don't get the same value, but you can see they approach to each other. Okay, so in this case, you can just kind of average, or you can use a little bit of kind of educated kind of estimate. So this will equal to 0.3 repeating. Okay, it's going to be 0.33333. Okay, or 1/3. Okay, or equal to 0.333. Okay. Or you can just take the 3 decimal places. That would be fine too. Okay. Again, this is not, some of this you're not going to get exact answers because you're just kind of estimating. Okay, let's go to number 5. Okay, you have the limit of sine of x over x as x approaches to 0. Okay, now this one you make sure you put in the radian mode. So make sure you calculate it's in the radian mode. So again, it's very important, put your calculator in the radian mode. Okay, and this one when you use positive and negative, give you the same value. Okay, so yeah, plus or minus 1, plus or minus 0.5, plus or minus 0.1, plus or minus 0.005, plus plus or minus 0.5, and plus or minus 0.01. Again, you enter your calculator, you're going to get 0.8415, 0.9589, 0.9983, 0.9996, 0.999. If you look at more digits, you're going to get 0.9998. So essentially, when you would run it up, if you run this up, you're going to end up equal to 1. Okay. Again, if you run this up and you push all these digits into 1, so answer will be equal to 1. Okay. Let's go to number 7. Here, number 7. Again, they want you to use the table to estimate. So you have the limit of x plus 4 over x squared plus 7x plus 12, and x approaches to negative 4. Okay, so over here you're going to get x, and so this one they don't give you any value, so you get to choose your value. So you don't have to make so many numbers. So again, you put a number right in the middle. So you want to approach to negative 4. So you put a negative 4 right over here. Think about this as a number line. Okay, and I'm not going to get 6 values. I'm just going to get 4 values. Okay, so negative 4. Again, think about your number line. So I'm going to make this negative 4.0001. And on the other side of it, we give you negative 3.9999. Okay, and I'm going to make a negative 3.99, and over here negative 4.01. So I'm using the 2 decimal places and 4 decimal places. So I have something to compare. Okay, again, when you use calculator, put parentheses when you're using the calculator. Okay, put parentheses when you're using the calculator. So enter this into this over here, you're going to get negative 0.9901, and this will give you negative 0.9990. Over here, you're going to get negative 1.0101, and over here you're going to get negative 1.0001. So again, you can see that they're going to approach to negative 1. Okay, again, you can see that this get close to negative 1, this also get closer to negative 1. Okay. So this will equal to negative 1. And if you're not convinced, you can go and do more additional value, make into negative 4. Instead of 4 digits, maybe you use 6 decimal places. Right? Instead of 4 decimal places, try to use 6, and you can see the pattern. Okay. Okay, let's go to number 9. You have limit of 5 to the x minus 3 to the x over x as x approaches to 0. Okay, so you got the x, you have f of x, and put the 9 in the middle. This approaches to 0, so this will be a 0. Again, I'm going to just get the 4 values. And I'm going to make this, again, think about this as a number line. Okay. So this would be negative 0.001. Again, I'm using 2 decimal places and 4 decimal places. Okay, and over here, and but now I'm going to make it into 3 decimal places. Probably give me a better estimate. Okay, give me a better idea. Okay, so you don't always start with the 1, okay, and -1. You already can start someplace close already, but make sure you get additional decimal places so you can see the progression. Okay, so enter you get 0.5101, and you get 0.5107. From this you get 0.5115, 0.5109. So you can see that it started. Notice it's all 5151, right? And it get kind of close. So if I were to guess, it's probably going to be 0.5108. Okay, but I'm just going to, again, when you use calculator, make sure you use parentheses, okay, in the calculator. And I'm just going to stay with 0.51 because you got 5151. Okay, if you want to be more exact, you can go 0.5108. Because you can just kind of look in between the two, right? Okay, let's go to number 11. Okay, you're looking for the limit of 1 over natural log of x minus 1 over x minus 1. Okay, so in this case, as you enter your calculator, make sure you put additional parentheses over here. Make sure you put additional parentheses, okay? That way avoid careless mistakes. Okay. Again, use a lot of parentheses when you're using the calculator. That would be a safer thing to do. Okay, so you got x, f of x. Okay, and again, right in the middle, you approach it to 1, so that's your 1 over here. So write a 1 over here, that way you can use that as a guide for your number line, and you can see what needs to be done. So this would be 1.0001, and this would be 0.9999. Again, 4 decimal places and 3 decimal places. Okay, and I get 1.001. So enter all the numbers in there, you're going to get 0.5001, 0.5000. This one you're going to get 0.4999. And this one, if you it's going to be 0.499999 something, but if you run it to 4 decimal places, you end up with 5000 anyway. So from here you can see that it's going to be equal to 0.5. Okay, let's go to number 13. Okay, on number 13. Okay, number 13. If you look on the graph over here, okay, so this one you have to use a graph to answer all this question. So for A, you're looking for the limit of function of x as x approaching to 1 from the negative. So here's your -1, and you want approach from the negative side. So an approach to here is going to equal to 3. Part A, -1. Okay, limit of x from the -1. Okay, so this would be equal to so here's your approach 1 from the negative side. So here's your 1. You approach from the negative, so you're going to end the answer is equal to 2. Okay. So over here, so part A, the answer is 2, okay, because it approaches the 1 from the negative side. That's what it means. Okay, over here, the B, it approached the 1, here's your 1, it approached from the positive side. So it approached, so the answer would be approached to this point, so the answer would be 3, okay? Okay, so the answer would be 3. Okay, now you go to C, it approached to 1. Now notice there's no plus or minus, means it approached from both sides. So here's your negative 1. So it approaches from this side and from this side. Notice it have different values, so the limit does not exist. Okay? Okay, so C, the limit does not exist because it approaches different values. Okay? In order to have a limit exist, you have to approach to a value. Okay, now you go to D, it approaches to 5. Okay, so here's your 5. So it approaches from both sides. So again, from this side, notice even there's no dot over there, it doesn't matter because it's limit. So it's talking about approaching. So you're approaching from this side, it gets closer to 4. I see over here is 4. When you're coming from this side, it can approach to 4. So answer for D is 4. Okay, so over here is 4. Now you go to E. Okay, the E is function at 5. Okay, so you want to evaluate when it's no limit, when it's just a function, means you want to find out what the value of over there, right? Now, so when x equal to 5, the f of 5, that's empty dot, so nothing over there, so it's not defined. Okay, so that's number 13. So this is number 13. Now let's look at number 14. Okay, for number 14, do the A. So it approach to 0 from both directions. So here's your x equal to 0 and approach from both directions. So answer would be equal to 3. Right, so answer would be 3 over here. Okay, now look at the B. It approaches 3 from the negative side. So here's a 3, and it comes from the negative side. So it will approach to 4. Okay, so the answer would be 4 right over here. Now for C, it approached the 3 from the positive side. So here's your 3, and it approaches the 3 from the positive side. So you can follow along, come from the positive side, it will approach to 2. Okay, so answer would be 2. And for part D, it approached the 3 from both directions. So here's the 3, so it approached from this side and this side. Notice it didn't connect. It does not connect, it has different value. So the limit does not exist, okay, for D. Now look at E, you want to evaluate the function at 3. So over here, so you're looking for the dot itself, okay? So you can make sure you know the difference between all these. So f of 3, that means you're looking for y value at x equal to 3. So when x equal to 3, the dot right over here, so itself will equal to 3, okay? Okay, let's go to number 15. Okay, so here's number 15. So part A, you're looking for the limit as approaches to 0 from the negative side. So here's a 0, you approach from the negative side. So you come through here, so you're going to approach to negative 1. Okay, so the y value will be negative 1. Okay, for B, so again, negative 1. Okay, so A is negative 1. Now, when you do the B, it approaches 0. Here's your 0. It approaches 0 from the positive side. So you're coming through this way. So you're going to approach to negative 2. Okay, so part B would be negative 2. Okay, next one, the C, it approaches to 0 from both directions. So over here, it approaches from both directions. So from the positive direction, from the negative direction, it does not connect. So the limit does not exist. Okay. Now you go to D. Over here, approach to 2 from the negative side. So here's a 2. You approach from the negative side. So from this side, or from the negative side. So approach this way. So answer equal to 2. Okay. So answer equal to 2. And the E, approach 2 from the positive side. So it's just 2, and from the positive side. So go from this direction. So approach to 0. Right. You get to 0. And then you have the F, approach to 2 from both directions. So here's a 2, you approach from both directions. Again, they don't connect, and so you have different values, so the limit does not exist. Okay, limit is like your asymptotes or like the boundary, right? Okay, so now you go to G, you want to evaluate the function at 2, so at 2 the function is equal to the dot. Okay, so it's equal to 1. Okay, over here. Now you go to H. Okay, you want the function to approach the 4 from both directions. So here's a 4, and you come from both directions. So come from this way, so it's going to approach at 3. Okay, the answer would be 3. Okay, well over here, so 3. Okay, so that's number 15. Okay, let's go to number 16. Okay, number 16, you're looking for the limit approach to 3. So here's a 3, and you want to approach from both directions. Let's see. Okay, here's a 3, and you want to approach from both directions. So answer equal to 2. Okay, so answer equal to 2 over here. Okay, now do the B, the limit approach to 1 from both directions. So here's a 1, and you approach from both directions, so it'd be -1. Okay, so it'd be -1. Again, it's approaching. Now C, you want to approach to -3 from both directions. Okay. So again, this is approach to -3. So here's -3, and approach from both directions, so answer equal to 1. Okay, so answer is 1. Now you go to D, you want to approach the 2 from the negative direction. So again, you have to understand what all this means. Okay, so you want to approach the function, approach the 2 from the negative direction. So here's a 2, right? So you want to approach from the negative side. So you come along here, so it will equal to 1. It will approach to 1. Okay, now let's go to E. You want the function to approach the 2 from the positive side. So here's a 2, and you want to approach from the positive side. So you're coming from this side, so you will approach to 2. Okay, so answer is 2. Now for the F, you want the function to approach the 2 from both directions. Okay, so here's a 2, and you want to approach from both directions. Again, they have different values, so the answer is the limit does not exist. Okay.